Okay, let's continue. So what you've sort of learned so far is the join keyword, the on keyword, and this dot notation in order to make those things that are inconsistent or duplicate, or to remove ambiguity. And then the as keyword when used in shortening up a table name. If you got a table name that's this long and you got to use it like 5 times in a query, go ahead and shorten it up to like 1 character or maybe 2 characters, so you just have less typing to do. Okay? Okay, good. On page 113, they start talking about a recursive relationship. It is perfectly normal, for example, to have a table that has a relationship with itself. I know that sounds a little weird. Now, let me give you an example of one that would kind of sort of make sense. Let's say you had an employee table that lists all your employees, but over on like one of the columns you put like the supervisor. So the supervisor is an employee, okay? So every employee has to have a supervisor. So there's an inner join you can do inside the one table. It's weird. Instead of having 2 separate tables, like a normal example, recursive relationship is one where you can do a join inside just one table. It's kind of weird. And we're going to hold off on that. We're actually going to do a demo of that, but some other chapter. Okay, so the next thing we need to talk about is on page 114 is the join types. Okay, now this is something that you're really just going to have to wrap your head around. So I'm just telling you in advance, slow down, take a deep breath, and try to understand what we're talking about. All right, what we've been using so far is called an inner join. And what that means is only give me the rows on this side that have matching rows on that side. If something is missing over here, it doesn't show up. And if something is missing over here, it doesn't show up. So it only has to be all those things that exactly match every single time. Now, sometimes that's not what you want. Sometimes you might say, but wait, I want all the rows from the left and only those things that get added on the right-hand side. Okay? In other words, every row is going to be represented. And if there's not something matching, well, just leave it blank. You know, don't remove the row, just don't fill in the extra information. So that would be considered a left join. The right join is the exact same thing. I want all the rows on the right, and then just give me the match, fill in the data if that matches. If it doesn't match, that's okay, just don't fill in the data. Okay. So that's kind of a weird scenario. All right. So let me just go through it. So inner join is all the rows have to match. Every row on the right has to match at least one column on the left. So left and right have to match. If any one of them is missing, we don't get the output. A left join means all the rows on the left, and they just add in the columns on the right. And the right join is all the columns on the right, just fill in the stuff on the left. And there's another one called an outer join, which basically says, give me all the rows on the left and all the rows on the right, and it's okay to have holes. Okay? That's kind of weird. All right? So those are the 4 types. The inner join, the one that we do most common. Left join, right join are kind of easy, and then the outer join is a little bit more complex to understand, to wrap your head around. So, for example, I don't ever expect to see any null data get generated in an inner join, but it is possible that null data would be generated in a left join, or a right join, or this outer join thing. Okay, so I've got a special database here used to describe what I call the Venn diagram. All right, this is crazy data. So here's some data, and it's just a customer, and they got their first name and their zip code. And so I've got some, where here all the zip codes are different, and then I have a warehouse and with the zip code, and all the zip codes are the same, and then I have another one where all the zip codes are different. All right, so it's all about the zip codes. All right, so if I was to say, what is the maximum number of rows that you can have? So there are 3 rows in this table, and 5 rows in that table. So we should be able to tell without even running the query. We should be able to figure this out. Okay, here's how it would go. the maximum number of rows you could have is every row on the left matches every row of the left. The first row matches all 5. The second one matches all 5. The third one matches all 5 for a total of 15. So it's actually pretty easy. If I said, what is the maximum number of rows you're going to get with a table that had 3 rows and 5 rows, you'd say, well, 3 times 5 is 15. And you'd be done. Woohoo! So sure enough, I get 15 rows of data. Now, is it humanly possible that when I run a query, absolutely nothing matches? Is that possible? Yeah. Okay, so the minimum number of rows you could have is 0. All right, let's do the left join. So for the max, it's still going to be the same. It's possible that every row would match every other row, so you still got a 15. But when it comes to the minimum number in a left join, it's always going to be the number of rows in the left table, right? See, I just get blanks for the stuff that I don't have data for. Same thing for the right join. For the right join, I get 15, just the way you'd expect. But the minimum, I get, okay, I still get my 3, but I just get blanks in here. Okay, now the reason why I'm telling you all this, other than the fact it's going to be on the quiz, is that this is useful. I've been in situations where I'm writing a join and I think I got it right. I think okay, I got it. And I hit the button and I get, 10 million records. And I'm expecting a lot less. If I only have 100 employees and I'm doing some employee report and I end up with, 100,000 rows, I go, I bet I picked the wrong type of join. Okay, so that's the reason why you need to learn the minimum and maximum number of rows that are expected in join types, because you'll make a mistake and you look at the output and go, oh, okay, I really needed a left join because I want all the rows over here and only the matching stuff over there. So that's the reason why we teach this thing. There's some stuff in here that talks about how you could look at this like a Venn diagram. I don't know if that's very useful or not, but it talks about, there's a website that shows this stuff, and I don't know. So I'm not certain this is actually any helpful or not, but, select something from left join, and then right join, and then an inner join, and, I don't know, maybe it's useful. I can't really tell. Okay, so we are going to continue on. The next thing we probably need to learn is the thing about how to join multiple tables, okay? So if I have select from table 1 and then table 3, from table 1, you just keep, the way you do it, you should keep going. You say, join table 2 on, whatever that is, and then join table 3 on, whatever that is, and you just keep going. So the way you would do multiple joins is you just kind of stack them up. And you do have to kind of pay attention to the order in which they come in. For example, I can't refer to a particular table until after the join part is complete. Anyway, when you're doing multiple joins, this is how it looks. Okay. I tell you what, the only way you could ever learn how to do this is, of course, doing it yourself. You can't go in there and watch me and make any sense of this. You're just going to have to go do the joins yourself. On page 118, they talk about the set operator. Okay, so the set operator, now, first of all, if you remember back when we had the list, what I call a list operator, using the in keyword, remember that guy? Okay. I don't like two things called set, so that's the reason why I call the first one the list operator. The set operator is for combining tables, but not like this. It combines the tables like this. In other words, it takes all the table data and it just sticks another one on below it. Okay? It's sort of like, copying and pasting 2 Word documents and just putting one underneath the other. That's all. Okay? It's not all that complicated, I don't think. So, again, how useful is this graphic? Maybe it'll be helpful. So, a union of these things means I have all the data over here and all the data over here, and they stick together. And then the intersection is only where they match. I don't know. It's kind of weird. So, a union. So I'm going to do one to make this have some relevance of sense. So these two things look very similar. The catalog and the catalog SKU 2019, right? That looks very similar to the catalog SKU 2020. The data is different, but you know, the structure is the same, okay? So what I'm going to do is I'm going to go here and I'm going to do a union on these guys. Okay. So I'm going to go here, I'm going to go back to this guy, I'm going to go back to my SQL. And so I'm just going to type in two complete statements. I'm going to say select asterisk from catalog SKU 2020. Then I'm just going to say union and then type the other one. Select asterisk from catalog SKU 2021. And I hit the button and it just boom, punks them together. Okay, so I'm going to do something slightly different this time. I'm only so there's 18 rows, okay? Kind of keep that in your mind. 18 rows. So now I'm going to say, I just want the list of SKUs from each one of these guys. And I end up with 11. And you might think, wait a minute. You told me to just stack them together. Well, this is an oddity in the SQL world where the default option is to remove duplicates. That's kind of odd. I don't know if that many other places. If you really want them without removing, you say union all. Okay, and that'll get you back with the same number we had before, the 18. Okay, so the union operator. I'm not going to demo the intersect and the except thing. That's basically what this little Venn diagram is all about. And once again, I'm not sure how useful that is. Okay, there's a couple of terms we need to talk about, and that is a term. This is not in the book. A term called a selection. It's a database term. You may hear it sometime, particularly if you're a programmer. You may hear these terms. The selection is the rows that appear in the output. So the selection is not the select command. The selection is typically like the where clause. Okay, and the other is called the projection, and the projection is the columns that appear, which could be the select and you know, maybe a join keyword or something. Okay, the reason I'm telling you this is because later on, you know, you might be going along and doing something, and I was typing in a program, and it came up and told me that I needed I couldn't do this because I needed a new projection, and I went, projection? What the heck is that? So that's the reason why I'm explaining all this, the difference between a selection and a projection. Okay, so let's just talk about the things that kind of sort of sound like test questions. You know, I like rules, okay? So do you remember what the rules for group by was? It had something to do with, you could have aggregates in there, like a sum or an average or something like that, a count. You can have multiple ones of those, but you can't add an ordinary column in there by itself without using a group by, okay? So the group by is the thing that determines how many rows of output do you want. So if I have 100 rows in my table and I want to have 100 rows in output, there's no need for you to use a group by. If I only have one row of output, I probably don't need to use a group by. But if I have 100 rows in my table and I'm expecting somewhere around 10 rows of output, I'm going to be using a group by. So group by groups things together, right? It makes them thinner, so to speak. Logical operator. Okay, you guys remember how this thing works? If I walk up to a counter at McDonald's and say I want a Diet Coke and a hamburger, I get two things, right? But if I say I want a Diet Coke or a Diet Pepsi, I only get one thing, and that's exactly backwards to the way things work in the database world, okay? In the database world, the and is going to make things smaller, and the or is going to make things larger. Okay, we're coming up on the 15-minute mark, but it only got a little bit more to go.